Chapter 5 1. You identify the linear fractions by finding that a constant change x corresponded to constant change in y. The difference between y value of a constant in x value are called first differences. For example, the first difference of y equal x squares are 0, 1, 3, 5, 7. The second difference are 2, 2, which is also a constant change. Notice that the quadratic function y equal x squares does not have constant first differences. It has constant second difference. This is true for all quadratic functions. Example 1a. Identifying quadratic function. Tell whether the function is quadratic. Explain. Since you are given a table of ordered pairs with a constant change x values, see if the second differences are constant. Find the first differences, then find the second differences. The function is not quadratic. The second differences are not constant. Cautions. Be sure there is a constant change in x values before you try to find first or second differences. Example 1b. Identifying quadratic function. Tell whether the function is quadratic. Explain. Since you are given an equation using y equal ax squared plus bx plus c, this is not a quadratic function because the value of a is 0. Tell whether the function is quadratic. Explain. Y minus 10x squared equal 9. Try to write the function in the form of y equal ax squared plus bx plus c by solving for y. Add 10x squares to both sides. This is a quadratic function because it can be written in the form of y equals ax squares plus bx plus c, where a equals 10, b equals 0, and c equals 9. Helpful hint. Only a cannot equal 0. It is okay for the values of b and c to be 0. Example 1a. Tell whether the function is quadratic. Explain. Since you are given a table of ordered pairs with a constant change in x values, see if the second differences are constant. Find the first differences, then find the second differences. The function is quadratic. The second differences are quadratic. Tell whether the function is quadratic. Explain. Y plus x equal 2x squared. Try to write a function in the formula of y equal ax squared plus bx plus c by solving for y. Subtract x from both sides. This is a quadratic function because it can be written in the form of y equal ax squared plus bx, where a equals 2, b equals minus 1, and c equals 0. The graph of a quadratic function is curved called parabola. To graph a quadratic function, generate enough ordered pairs to see the shape of parabola, then connect the points with a smooth curve. Use a table of value to graph the quadratic function. Make a table of value, choose value of x, and use them to find value of y. Graph the points, then connect the points with smooth curve. Use the table to graph the quadratic function. Y equal minus 4x squares. Make a table of value, choose value of x, then use them to find the value of y. Graph the points, then connect the points with a smooth curve. Use a table of value to graph each quadratic function. Make a table of value, choose values of x, and use them to find value of y. Graph the point, then connect the point with a smooth curve. As shown in graph in example 2a and 2b, some parabola open upward, some open downward. Notice that the only differences between two equations is the value of a. When a quadratic formula is written in the form of y equals ax squared plus bx plus c, the value of a determines the direction the parabola opens. A parabola opens upward when a is bigger than 0. A parabola opens downward when a is smaller than 0. Tell whether the graph of quadratics functions open upward or downward. Explain. Write a function in the form of y equals ax squared plus bx plus c by solving for y. Add 1 out of 3 x squares to both sides. Identify the value of a. Since a is bigger than 0, the parabola open upwards. Write the function in form of y equals ax squared plus bx plus c. Identify the value of a. Since a is smaller than 0, the parabola open downwards.